Hello everyone, I'm Michael Jan Cardente and I'm here together with my group mates Joel Canabe and Jason Bergado to discuss about the topic chapter 3, which is the metal reinforcement. So to start, metal reinforcement. So for the steel reinforcement, steel is the most widely used reinforcing material for almost all type of concrete constructions. It is an excellent partner of concrete in resisting both tension and compression stresses. Comparatively, steel is 10 times stronger than concrete in resisting compression load, and 100 times stronger in tensile stresses. So, the design of concrete assumes that concrete and steel reinforcement act together in resisting load and likewise to be in the state of simultaneous deformation. Otherwise, the steel bars might slip from the concrete in the absence of sufficient band due to excessive load. So in order to provide a high degree sufficient band between the two materials, steel reinforcing bars with a surface deformation in various designs were introduced. So as you can see here in the figure, it is a figure about types of deformed bars. So this first bar is called spiral shape, and this in the middle is called herringbone shape, and lastly the crescent shape. And this is the what you call the size of the bars. It is the example of it is three types of deformed bars. So we have a table here. So first table is the standard weight of plain or deformed round steel bars. So it has the sizes and in weight, which is in kilograms. Then the next table would be deformation requirements. So it has a nominal diameter, maximum average spacing of lugs, height minimum, tolerance maximum, and last column would be the maximum value summation of gaps of lugs, which unit would be in millimeters. So another table here is in mechanical properties. So we have a class. So it has two class, the hot rolled non-weldable deformed steel bar and the hot rolled weldable deformed or plain steel bar. So it has grade, yield strength, tensile strength, specimen, elongation in 200 millimeter percent, in 200 millimeter rather, then bending angle degrees, and lastly the diameter of pin. So next is the identification of steel bars. So steel reinforcing bars are provided with distinctive markings which identify the name of the manufacturer with its initial and the bar size number including the type of steel bars such as N is for belay and A is for axle, rail sign is for rail steel. So as you can see here in the figure, so the upper part would be would be called the main ribs, followed by the initial manufacturer, which is this letter M here, and sa ubos niya is ang iyang bar size. Then next is the steel type, and lastly iyahang grade mark. It is mo ni siya ang marking system para mo ni siya ang pag-identify sa steel bars. So bars, splice, hook, and bend. So in estimating the quantity of steel, reinforcing bars, one has to consider the additional length for the hook, the bend, and the splice, whose length varies depending upon the limitation as provided for by the National Building Code. So it has a small table here, the types of reinforcement and its minimum splice length. So one is tension bar is equal to 25 times the bar size plus 150 millimeters. The second is compression bars is equal to 20 times bar size plus 150 millimeters. So we have image here. So for this figure, we have been given the figure para sa formula, kung saan pagkuha sa formula sa kaning mild steel minimum hook and bend allowance. So for this, the formula would be the hook length is equal to the length times the height for the hook. Kini mo ni siya ang allowance, mo ni ang formula sa hook length. So the second would be the high yield bars minimum hook and bend allowance. So its formula would be the hook length is equal to length plus n for bend. So the next figure would be the high yield bars minimum hook and bend allowance. Mo ni ang kani upat ka image is mo ni siya ang high yield bars minimum hook and bend allowance. Dili ni siya mao. Sayop ko ganina. Then the formula of this would be length is equal to 2a, which is a iyahang sa taas makita sa figure, a 2a plus 3b plus 22, which is ang 22 is ang size sa imong bar. Then next is the length would be a plus c. Muna siya ang total length sa bar. Then next is the length is equal to 2 times a plus b plus 20, which the 20 is the size of the bar. Then next figure, the total length is equal to a plus b plus c. Muna siya ang total length. So next figure will be this, the total length is equal to a plus b plus c and also plus d. Kani nga image. Then kini pod is, ang formula is the length is equal to A plus B plus 1/2 of R. Kaning bending kaning image niya diri. Then the last diri sa kuan figure is L is equal to A plus 2B minus 2R. Kani 2R. At minus plus D plus C minus 4. Another is the total length A, then total length is pagkuha ni sa total length kani. Total length is equal to A plus the H. Diri is A. Then diri figure is total length is equal to A plus B minus 1/2 R minus the size. Dayon kani is total length niya is equal to A plus 2H kani nga figure. Moving on to the another. Yang total length would be A plus H. Pareha Japan sila. Dayon kaning isa total length niya is A plus 2H. Sen naman i-add nimo siya bali i-add lang nimo ang length sa kani pataas diri o padulong po din diri. I-add lang nimo yung total length. Maragyapan diri then kani yung formula is total length is equal to A plus B plus C minus R minus 2 theta. Then total length is equal to, then last is total length is equal to A plus B plus C. So, the size of steel reinforcement and its quantity is one item of construction which is quite difficult and it is also complicated to determine. Difficult in the sense that it requires patience and deeper analysis in computing the actual number of bars required to be used in every part of the structures. Estimating is done in a systematic approach that is computing the quantity of each member one at a time, item by item, then summarize the result according to its size and quantity in conformity with the commercial length of steel bars to avoid excesses and unnecessary cutting. Ordering materials that is more than what is actually needed in the construction will only invite pilferages and encourage reckless cutting, which is in effect contributory to the construction waste. Also, estimating the quantity of the steel reinforcement refers to the commercial length of steel bars to be ordered as summary of all the cut bars intended for the different members of the structure. Under such condition, the following problems has to be anticipated. So, 1. For main reinforcement of post, columns, beams, girders, and the like is determined by the direct counting method, wherein the additional length for hook, bend, or lapping joints are often overlooked. So, 2. For other structural members such as lateral ties, stirrups, spirals, dowels, cut bars, and the like should be treated separately and carefully determine the length of their cuts, including the allowance for hooks and bends. Number 3. After knowing the length of the lateral ties, stirrups, etc., the next problem is how to select the steel bars to be ordered from the various commercial length of 5 meters to 13.5 meters, avoiding extra cuts which might be classified as junk unless they could be of service or used on other structural members. And number 4, tie wire for reinforcement joint is a big item of a large construction work considering its cost. The cutting length of each tie wire should be the minimum required based on the diameter of the bars to be tied. So we have a table here, areas of groups reinforcement bars. Concrete hollow blocks. The next is concrete hollow blocks reinforcement. So in our previous discussion of masonry in chapter 2, the concrete hollow block work and been thoroughly discussed, giving emphasis on how to determine the quantity of blocks, cement, sand, and gravel, except the steel reinforcement which is necessary to complete the work. The size and spacing of CHB reinforcement depends upon the plan and specifications, which is basis of the estimate. The number of steel bars required could be determined in 3 ways, which is by the direct counting method and by the unit CHB method and also the area method. So the direct counting method could be done by counting directly the number of vertical and horizontal bars plus the lapping, hook, and bend from a detailed plan. But how many plans have presented a detailed drawing for steel reinforcement? So the area and unit CHB method, this is the simplest method of computing the steel reinforcement for CHB with the aid of table 3.4, wherein the values represented includes allowances for supplies and beds. So we will look, tanaw na to ang table. Ano siyang table? Length of steel reinforcement for concrete hollow block work. So we have the spacing, the length of the bars in meter, spacing na sa then length of the bars in meter. Which is, the first is the vertical reinforcement, ang lahi na sa din ang horizontal reinforcement niya. So maggamit ni nato sa next slide, which is ang katunang example niya. So for example, from figure 3.6, determine the number of 10 cm CHB and the vertical reinforcing bars placed at 80 cm on center, including the horizontal bars at every after 3 layers. So kani. So na siya duha ka solution. Ang first solution niya is number 1 is solve for the area of the fence. So area would be length times height. So sa given niya na siya length na 4 and height na 3, area would be 12 square meter. So next, number 2 would be vertical reinforcement 80 centimeter. Referring to the table 3-4 by square meter or area method, mo to gi-refer to siya sa table kani which is the 80 centimeter para 80. So ang gibuhat is ang 12 times mo sa 160 ang 12 times mo sa 1.60 kay there is a table ang 18 niya is na iyang bars in meter 1.60. So the answer would be 19.2 meters. Then convert this value to the commercial length of steel bars ranging from 5 to 13 meters. Select the most economical length avoiding extra cut. So select 4 pieces 10 millimeters times 5 meter long. Then number 3 is horizontal bars at every after 3 layers. So balik na sa table 4. Based sa table 4, ang iyang is 2.15. Tara, 3 layers. Spacing in layers. Number 3, it has 2.15. So ang buhaton is 12 iyang area times the 2.15 is equal to 25.80 meters. And then select 4 pieces at 5 meter and 1 at 6 meter long. Lastly, number 4, order 8 pieces of ang answer niya is 8 pieces 10 millimeters times 5 meter 10 millimeter by 5 meter steel bars 1.1 to 10 millimeters by 6 meter steel bars. So for the second solution, ang iyang gibuhat una is solve the area of the fence. Magyapon yung area kay 12 square meter. Then determine the number of CHB. So yung area times 12.5 is equal to 150 pieces. Then referring to the table 3-4, vertical reinforcement per block 80 meters. Tama natin ganina nga 0.128. So ang answer niya is 19.2 meters. So next is B is horizontal bars in every after 3 layers. So 150 times 0.172 is equal to 25.8 meters. Then convert to the commercial length. 4 pieces of 10 millimeters by 5 and 1 at 6 millimeters long. So order 8 pieces 10 millimeters by 5 and 1 to 10 millimeters 6 meter by 6 meter steel bars. Parehas lang answer. Lain lang siya og solution. So another here is the tie wire for steel reinforcement. Gauge number 16 galvanized wire is commonly used as tie wire for steel bar intersection and splicing joints. The length of each tie wire depends upon the size of the bar to be tied on. Tie wire is one item of the construction which is always included in the bill of materials without the support of computation. Its quantity is mostly determined by the estimator through mere calculation, which is somewhat alright for a small work but not for a large construction involving multiple floors. The imaginary estimate for tie wire will never give a satisfactory result. CHB reinforcement tie wire. The common size of steel reinforcement for concrete hollow blocks are either 10 mm, 12 or 13 depending upon the plan and specifications. For those particular size of reinforcements, a 25 cm or a 30 cm long tie wire folded at the center will be satisfactory. So, table for kilogram of number 16 tie wire of concrete hollow blocks reinforcement. So, continuing the solution of illustration 3.1 from following data obtained. So, vertical reinforcement spacing is equal to 80 cm, horizontal reinforcement spacing every 3 layers area of the wall is equal to 12 square meter. The solution is first is to determine the number of CHB. So, to determine the number of CHB, 12 times 12.5 would be 150 pieces. So the second, using a 25 centimeter tire wire from table 3.5, multiply. Tire wire is equal to 150 times 0.0016 is equal to 0.24 kilos. So that would be all. Did I? The next reporter will follow. Thank you.
Good day, everyone. My name is Joe.